In this video, we're going to talk about sampling and different types of sampling that you need to know about. Let's say we're going to run a focus group to gather more information on people's experiences on sugar-free Feb. We need to select a sample of 80 people to be contacted using each of the following methods of sampling. Simple random, systematic, stratified, opportunity, quota, and cluster sampling. Now, a sample is a subgroup of our overall population. It may be a perfectly representative subgroup, or it may be biased in some way. In our project, the population is everybody who took part in Sugar-Free Feb, and the 2,000 volunteers whose data we have, they form a sample of that population. So we already have a sample here. We don't actually know how big our entire population is because not everyone tells us that they're taking part in Sugar-Free Feb. Not everybody registers, and so we don't know how big the population is. But for the purpose of this project, we're going to assume that our sample of 2,000 volunteers whose data we have, we're going to assume that they are representative of the population. That is to say that we have the correct spread of age, gender, motivation, etc. Now, what we're going to be doing here is we're going to be taking a further sample of that sample, a sample of 80. There are lots of reasons why samples are useful. Firstly, it will usually be far cheaper and quicker to collect data from a sample than from the entire population. And, as mentioned, sometimes we don't even know who the entire population is. In situations such as product testing, using the whole population would be impractical. For example, if an elastic band manufacturer wanted to test the breaking point of their bands, stretching all the bands until they broke would leave them with no stock, and so testing a sample of the bands would be the best option, the only option here. Now, there are risks involved as well. If we have a biased sample, for example, one with too many men or one with too many young people, then our conclusions might not then apply to the entire population, and that would make our analysis redundant. So it can be difficult to select a truly representative sample. The person who is in charge of selecting the sample really needs to understand the context of why you're selecting a sample, what's going to be done with the results, what factors they need to think about when they're taking their sample. The first type of sample that we're going to look at is a simple random sample, and this is one where every item in the population has an equal chance of being chosen. Now, in this context, every item has an 80 in 2,000 chance of being chosen. That's 80 over 2,000. That's a 4% chance. This is really easy to do in Excel. So head to your Data tab, and we're going to insert a new column called Random. And we're going to use the rand function, so equals rand, and then nothing in the brackets. Hit enter, and we're going to populate this column with random numbers between 1 and 0. So that's what rand does. If we double click, this entire column will be populated. If we copy those values and paste them over themselves just as values, then they won't change every time we try and do something. Finally, we're going to sort this column from largest to smallest. And then we're going to pick the first 80 people here in our sample. Now, this is a truly random approach. We shouldn't scan through the list to check that it feels representative. That defeats the whole point of this. We're just making this nice and simple. We're not doing any checks. So we'll create a new column, a binary column, to indicate whether or not each person is going to be included in our sample. So the first 80 people are going to be ones. Like so, that's 80. And then the rest are going to be zeros, and we can populate the rest with zeros quickly like that. Now, we can actually do some checks here to see whether or not this sample that we've taken is very representative of our sample of our overall 2,000. If we head to our pivot table and we need to refresh this because at the moment it hasn't picked up on those two new columns that we created. So if you click on the pivot table, go to Analyze, and then click on Refresh, you'll see our sample column has appeared here now. Now, what we want to do, if we clear the table, we just want to maybe look at the proportion of genders in our 2000. So drop gender in the rows and drop salutation in the values. And we're going to look at that by percentage. Choose percentage of column total. Now we can see that 69% of our 2000 are females, 31% are males. Now if we want to look at how many in our sample came out as male and female, if we drop sample in here as a column, now anyone that was given a 1 in the sample column is in our sample. Now our sample has got 78% females, 23% males, which is not too far off our overall 2000, but it's clearly not perfectly representative. So the advantages to a simple random sample are that it is quick and easy, and with a large enough sample, we'll probably end up with something fairly representative too. However, we are leaving ourselves open to chance that we could end up with quite a biased sample, which we do want to avoid. The next method that we're going to look at is systematic sampling. Now, this is where we order our data in some way, and then we take every nth person to achieve our total of 80. Now, in this case, because we've got 2,000 people in our sample, and we're going to try and end up with a sample of 80, we want to take every 25th person in our list. Now, let's clear our workings from before, head back to data, clear our sample. Now, we need to just order our data. Now, we can do that by doing a custom sort. If we go up here, click on custom sort, we're going to sort our data, first of all, by gender. Okay, it's just selected this column here. Let's get rid of that. First of all, we're going to sort our data by gender, but then within that, we're going to sort our data by age band. And then within that, we're also going to sort our data by motivation level. So what will happen here is that all of our females will be listed first. And then within that, all the youngest females will be listed first. And then within the youngest group, all of those with a motivation level of 1 will be listed first, and then all of those with a motivation level of 2, and so on. Now, we need to just select every 25th person in this list, and that will guarantee that we're going to get some young females who have varied motivation levels, and so on. Now, irritatingly, I haven't found a particularly quick way to flag every 25th row, but there is a workaround. First of all, go to the top, Control and Home. We're going to number our ordered data from 1 all the way down to 2000. So if we do 1, 2, 3, select those, double click, that will go all the way down to 2000. And then in a new column, we're going to use the mod function. Now the mod function tells us the remainder when we divide this by a particular value. And what we're going to do is equals mod, open brackets. Now what will the remainder be when I divide this number by 25? Close the brackets. Sorry, when I divide this number, comma, 25. And copy that all the way down. Now let's have a look at what happens. If I divide 25 by 25, the remainder is 0. If I divide 50 by 25, the remainder is 0. Now every 25th column has a value of 0 here. And so finally, to decide who we're going to take in our sample, we just want to take those where this column value is a 0. So equals if, open brackets, that number is a 0, then 1 for yes, we do want them in our sample, otherwise 0 for no. Close the brackets, copy it down, and we will see that only those that are multiples of 25 basically come out in our sample. If we select that entire column, we can see here that there are 81s in the column, so we've got our sample of 80. Now, this has forcefully removed some of the elements of bias that could come up in our sample. So we're guaranteed to get both males and females of all age groups, of all motivations, etc. And so in some contexts, this is a really good way of sampling. However, there are others where it might not be such a good way. If there are periodic patterns in our data, our sample is going to end up biased. For example, if you were interviewing every 50th person who exited a roller coaster, but the capacity of the roller coaster was 50, then every time you're going to be talking to the person who was in the same position on that roller coaster, maybe the person who was at the front or the person who was at the back, and that's going to bias our sample quite a lot. The next type of sample we're going to look at is stratified sampling. Now, this is where we split our population into groups called strata, and we look at how big those groups are, and then we choose our sample accordingly. Now, let's say we're going to stratify by gender and age. We'll use our pivot table to see what percentages of our 2000 are from each gender and age group. So if we clear it, if we pop age bands here and gender here, salutation in here, and show this as a percentage of the grand total, we can see that in our stratified sample, 13% should be females aged 26 to 35, 7.7% should be males aged 56 to 65, and so on. And so we would fix our sample to take that correct proportion from each of those different subgroups. Now, what we could do is we could maybe sort our data by age and gender, and then within that sort it randomly, and then choose the correct number from each group. Now we can tell exactly how many we need from each group. If we copy this table here and just paste the values, and if we do that again, and here we're going to multiply each of these percentages by 80 to say, okay, of our 80, how many do we need from each group? So equals that number multiplied by 80, and if we apply that to all the boxes, now each of these then is doing that number there times 80, that number there times 80. And if we turn these into whole numbers, we can see how many we need from each subgroup. We need 8 females who are aged 66 to 82 in our stratified sample, and so on, and that gives us a total of 80. The advantages of stratified sampling are that it would guarantee us a representative proportion of each of our strata, which is a big step towards a representative sample. However, we can't really stratify on every single variable, so they'll probably still end up with some bias. It's also quite time consuming to do, which is why we haven't gone ahead and done it all here. Perhaps the simplest type of sampling is opportunity or convenient sampling. And this is basically where we do the most convenient thing and just choose the first 100 people we come across. Sorry, the first 80 people we come across. Now, in our situation, if we just opened up that data file, chosen the first 80, that would have been an opportunity or a convenient sample. Quota sampling isn't much more complex than that. We would begin by specifying some quotas or targets that we'd like to hit. For example, we could have quotas of 60 women and 20 men, and then we carry out convenient sampling until we've reached those quotas and we're done. So this is quite often used in market research. You might have somebody stood outside a supermarket and their quotas are 30 men, 30 women, and so they just speak to the first 30 men they come across, the first 30 women. If they've filled up their quota of women, they'll ignore the next few women who come out and just try and target men. The quotas could be a bit more complex, so we could throw some quota for motivation in there as well. We could try and get 16 people from each of our 5 motivation levels, and so on. The final type of sampling that we're going to mention is cluster sampling. Now, if the population naturally sits in clusters, for example, a county like Cambridgeshire may be considered a cluster, and these clusters are all similar to each other, we could just sample from one of those clusters in the hope that that cluster were representative of the entire population. So if we wanted to find out something about everyone in England, but we assumed that all counties were the same or had similar attributes, then we could just focus on our sampling in one cluster in Cambridgeshire. And this would make things much cheaper than travelling in between different locations. But the risks are obviously that there may be underlying differences between the different counties, between the clusters, that would then cause our sample to be biased.